Hello everyone. So I hope you all are doing well and you are working towards your dream. So the problem today which we will be solving is the number of integers with pop count depth equal to k. So this is a classical digit DP problem. First of all, let me give you some brief hints about the problem statement and how will we approach this, right? So this is digit DP solution, right? So even if you don't know digit DP, no worries, I will make you understand it from scratch, right? So it might be a long video and I am recording it for the third time because every time there was some issue in microphone or in recording. So let's hope that this video reaches to you. So let's read the problem statement. So you are given two integers n and k. So for any positive integer x, define the following sequence. So p of 0 equal to x, right? P of I plus 1 equal to pop count of I for all I greater than 0, where pop count of y is the number of set bits in ones, right? Set bits, that is ones, number of ones in the binary representation of y. So this sequence will eventually reach the value of 1, right? So the popcount depth of x is defined as the smallest integer d greater than equal to 0 such that pd equal to 1. No languages, let's see what the question means, right? Let's say I had been given a number, right? Let's say I am given a number 7, right? So for 7, what now, see the mouse is not working. So for number 7, right, if you write the set bits, it will be 111, right? And now 111, it has 3 ones, so it will be converted to 3, right? So this 3 can be written in binary forms as 1 1, right? It has 2 ones, right? So it becomes 2. Now 2 1 can be written as 1 0. It has 1 ones and it comes to an end. So if you look closely, there are 3. The pop count depth of this 7 is 3, right? So you need to return number of integers from the range 1 to n, right, including both, right, who has a pop count of equal to k, right? Okay, so you might be thinking that why not traverse on these numbers, right, and found their pop count values, right, and return it, right? But if you look closely, right, even if you write any code which will be of time complexity at least big of n or might be greater than that, right, because you will be traversing from 1 to n, right? And if you see the constraints of this problem, it is n can be till 10 k power 15, right? So this indicates that we need to write a solution which works not in big O of n. We need to write something which is smaller than big O of n, right? So here comes the part which indicates you that you should use some other methods, right? Okay, so while you will solve any digit DP problem, right, the integer you might see everywhere is 64. Now if you think or if you know why 64 is there, let me clarify it once. Why 64 is being used everywhere? Because 2 to the power 64 is 2 to the power 64 is gives us a value which is greater than 10 to the power 18, right? So here the constraints is 10 to the power 15, but if you calculate till 10 to the power 18, like in code forces or code chef, the constraints are till 10 to the power 18. So it's better if you try to solve a generic if you understand how this a generic DP works, right? Generic digit DP works. It's just a fancy name, it's not that hard, right? Okay, so let's see a few test cases, right? Let's say I had n equal to 7, right? So what are the answer for these? 3, 5 and 6, right? And k equal to 2. So quickly let's look how the answer 3, 5 and 7, right, 6 are valid for k equal to 2, right? So if you write the binary representation of 3, it is 1 1, right? 1 1 will be converted to 2 and 2 becomes 1 0. So if you look, there are 2 values, the depth pop count depth is 2, right? Okay, So if you look at 5, so 5 can be written as 1 0 1, right? And it again becomes a 2, and 2 is 1 0. Still we had a one more value, right? And 6 is also written as 1 1 0. Again it will become 2, and the value is 1 0. It is also valid. Why 7 is not valid? Let's check it out also, right? 1 1 1, it becomes 3, and 3 has a value 1 1, which again becomes 2, and 1 2 will be written as 1 0, which has a depth count of 3, right? So that's the reason 7 is not answer. You can check all the other integers as well. These are the only two possible combinations, like 3 possible combinations, right? 3 5 and 6. Okay, so I hope the problem statement is clear to you, right? Now let's talk about how are we gonna implement that thing, right? So before diving into DigitDB, let's look at some other things we might need in this problem, right? So if you look closely, what am I doing is I'm first creating a count vector, right? And in that count vector I'm traversing from 2 to 64. Now I clearly made you understand that, see, if the number of set bits of an integer, right, is all till 264, right, means all bits are set, right? So I made you understand this number will be 10 to the power 18, right? So there is no sense, right? There is no sense of thinking that number of set bits could be greater than 64, right? It's impossible, right? So that's the reason we are traversing from 2 to 64, right? And in C++ we have a built-in popcount function, right, STL, which gives us the number of set bits in a integer, right? What do this mean? Let's say add a 7. So if you do a pop count of 7, built-in pop count, right, this will give you 3. Why it will give me 3? Because number of set bits in 7 is 3, right? Okay, so what I'm doing is first try to understand this part. I'm traversing from 2 till 64, and I'm calculating pop, I'm finding pop, and I'm doing count of I equal to count of pop plus 1, right? Now if you look closely now, this is doing nothing but finding the depth, right? Depth of a integer. How? Let's look at this, right? Let's take few examples so that it's clear to you, right? So let's say I had a count of, I'm adding count of 1 as 1, right? What does this mean? That, see, first of all, count of 1 means number of ways to reach 1 is 1, right? It's not DP, it's nothing, it's simply vector, we are storing the values, right? So if we do so, right, what will be the count of 2? Let's say count of 2 will be, if you do a built-in pop for 2, what will the value be, right? Built-in pop for 2 will give me a value 1, right? Because 2 can be represented as 1 comma 1 0, right? So it becomes count of 1, right, plus 1, right? So this gives me a value of 2, right? Similarly, if you do a count of, see, we calculated the pop count values over here. Let's look at 3 as well. It should give me a value of 2, right? This count function is not finding the number of values which are there. Its objective is simply different. I'm just storing the values, number of set bits over here, right? So count of 3 will be count of 2 plus 1, right? So number of set bits in 3 is nothing but 2 plus 1, 3, right? So this, I'm again repeating, number of, this is set bits, right? This only represents the set bits, right? Nothing more, right? So what is the main reason why are we using this count? You will get to understand this few minutes later, right? Okay, so by trusting these things, you can say that these parts are clear to you, right? That you are finding a count and you are traversing on it, right? Okay, now what I'm doing is I'm building my string, right? This string part, I guess everybody knows. Till, let's say my n was given as 7, so what will be my string? My string will be 111, right? I'm just converting this number into binary string, right? And how are we gonna do this? If you don't know that, let's say we had a 7, right? So 7 modulo 2, it will give me a value 1. So you will add 1 to your answer, right? And make 7 equal to 7 by 2, right? Making sense? 7 by 2 becomes 3, right? Now 3 modulo 2 gives me a value 1, right? Again 1 will be added and 3 becomes 3 by 2, which is 1. So 1 modulo 2 is 1. So you add again a 1 and 1 by 2 is 0 and you end the loop, right? So this is the way of making a string, right? Okay. So after making the string, what we are doing is we are traversing from I equal to 1 to s dot size and doing an I plus plus. Now what does this mean? Let's say you are trying to find how many set bits could you make, right, till n, till you reach n, right? Now see, as n is till 10 to the power 18, right? So it's pretty obvious that you can't traverse till 10 to the power 18, right? So this in itself gives you a hint that you should use some recursive or deeply approach which will be optimized, right? Okay, so what is the next step, right? So before moving to the next step, let's understand the topic digit DB in deep, right? Okay, so it might be little confusing if you are the first time learning the digit DB part for the first time, but trust me, it is very easy, right? Before starting it, let's say I said you a number, right? I said from 1 till 564, right? Find me all those numbers, right? Find me all those numbers whose sum of digits is equal to x, right? So you will say that's not hard, right? You can traverse from 1 to 564, calculate all the digits and check if that value is valid or not, right? But let's say the constraints were still 10 to the power 18, right? Now you can't solve, right? If I say the number find till 10 to the power 18, you won't be able to solve it, right? So how will you approach it? So you should make a recursion solve, right? Make a function called solve. Now what does this solve function do, right? This solve function will take an integer, right? It will, let's say, take an index, right? What is this index, right? Let's say I am making 564. So if I am standing at this position, I will give you few options. What are these options? I will discuss it. So you will be standing at some index, right? You will have some value, some k, right? Or let's say some x, right? And you will have a value called tight. Now what is this tight, right? Let's discuss this. So when you are at first position, right, and you got an integer 564, right, what are the possibilities you could place at this point, right? So the possibilities are 0, 1, 2, 3, 4 and 5, right? Is 5 a possibility? Yes, 5 is a possibility. Is 6 a possibility? No, right? Now let's understand what is this. So index point is clear first of all? Yes. So the next part is x, right? X is nothing but sum left, right? This function is nothing but sum left, right? So what I'm trying to make is understand you is tight. Now what is this tight? This is a very common term in digit DP, right? This tight means, let's say you place a 0 over here, right? No, not 0, let's take 1, because 0 might be very obvious or very vague knowledge for you. Let's take 1 over here, right? Let's say you added a 1, right? Now what are the possibilities for this position? There are all possibilities from 0 till 9. You can add any value and it will be valid, right? It won't cross the constraints, right? So this is non-tight value, right? This is non-tight value. Now what does this mean? This means nothing but your tight value became 0. Are you getting it? Why type value became 0? Because I put a 1 over here and I don't have any restrictions on further elements. Even if you put a 9 and 9 over here, it will still be less than 564, right? Obviously it makes sense. Okay, if you put 2 over here, still it will, you can put 299, it will be okay. 399, 499, so all values are in the range, right? What if you put a 5 over here? If you put a 5 over here, right, then comes the tight value, right? Tight value becomes 1, right? This is what I'm trying to make you understand. If tight value becomes 1, what does this mean? You have very few options left further, right? So you say my tight value is 1, right? This indicates your recursion to work efficiently on the constraints, right? So why tight is still 1? Because मान लो तुमने यहाँ 5 रख दिया, right? Now अब मैं अगला एलिमेंट क्या रखूँगा? I don't have fully control on it, right? So that's the reason tight becomes 1 at this place. कि भाई सोच समझ के रखना आगे जो रखोगे, right? Okay, let's move. Oh no, so tight becomes 1, right? So let's solve this recursive function, right? So how is this recursive function working? It's traversing. I'm traversing on all the index, right? And let's say if, right, let's say not if, right, let's make it simple for you. If for, as we are beginner in it, I'm assuming, so let's say if your tight is equal to 0, right, then what are the constraints, right? You don't have any constraints, right? You don't have any upper bound. You can start from any index, any value from 0 till 9, right? So what will you do? You will simply call a for I equal to 0 till I less than 9, right? And you can call this solve function again, and what will you do? You will reduce your sum, right? So index becomes index plus 1, right? X becomes what? X means the sum of the digits. Let's say you put a 5 over here, right? And let me take an example. It might not be that much clear for you if I don't, right? Let's say I said you make a sum of 7, right? So if you take a 5 at this position, right, or rather let's take if you take 2 at this position, right, so what does sum becomes? Sum becomes x minus this 2, right? And this 2 is nothing but a I, right? And your tight becomes the whatever the tight value was. If it was 0, it might be 0. If it was 1, it will be 1. No worries. As you can see, tight here is at least 0, right? Okay, so let's move to the next part. What if tight is equal to 1, right? This might also be the case, right? So if tight is 1, you need to find the upper bound, right? मतलब क्या, किस लिमिट को तुम क्रॉस नहीं कर सकते? That should be known to you, right? What does this mean? 564, right? This was the example we were talking about. So you can't cross 5, right? So upper bound is nothing but the array or the string, whatever you are storing it, right? S of index, let's call it, we have stored it as a string because we can't store it as a number, right? So int upper becomes S of index, and now you can traverse from for int I equal to 0, right? You can place 0 over here, you can place up till upper, right? But what did I made you understand over here? That if you are upper at the value upper means अगर तुमने इस position पे 5 रखा, right, that is the only position where tight becomes 1, else tight was 0, right? So what will you do? If your I is equal to upper, right, everything will be same, just that means what does this mean? Solve function will be called, index will become index plus 1, x becomes x minus I, and tight becomes 1, right? Else if that value is not upper, then what will you do? Everything over here will be same, this tight becomes a 0, right? And now you can further do your thing. So this recursive code must be clear to you, right? So if you know very easily that if you can write this recursive code, right, then you can memoize it as well, right? And if you can memoize it, it becomes easy for you, right? So this was digit TP thing, right? So few things which I must address till now, right? So if you reach till the end of the index, right, if index is equal to s dot size. S is what? S is 564, the string which we were talking about, right? So if you have reached over there, and if your x is equal to 0, right, then this means you have got a valid thing, so return a 1, right? Else return a 0, right? So base case is also clear to you, I might guess, right? So this was the recursive digit DP code, right? And if you have understood this recursive digit DP code, just tell me the few steps which you need to memorize it, right? How could you memorize it? What are the changing variables? So if you don't know, any recursive code can be memorized in simple one step. What is this step? This step is find the changing variables, right? Find changing variables. What are the changing variables? Changing variables are index, right? Is type changing? Yes, type is also changing. And the last thing which is changing is, what are the last thing which is changing is, if you see index you are changing, sum is changing, right? So this sum becomes sum, right? So these are the three things which will be changing for your DP, and this becomes state. So DP of index, type and sum are the three things which will be changing in your DP, right? And if you think closely now, this index, right, let's talk about the complexity as well when we have reached till this point. So this index is nothing but it can be at max 18, because 18 10 to the power 18 will have 18 string digits only, right? This type will be nothing but 0 or 1, right? What will be the sum? So in general competitive programming, what you do now, let's say we had 9, all 9s over here, right? So what will be there will be 18 9s, right? So 18 into 9s 162, right? So we generally tend to think that all the values are 10, right? And we take at the most value 180, right? So it becomes 180 over here, right? So if you now look closely, what is the time constraint of this DP problem? It is 18 into 10, 180 into 2, right? So 18 324, 324 into 10 over here, 3240 into 2. So it's roughly about 10 to the power 3. Great. So we have optimized the solution from something called recursive, right? Or rather big O of n, where n would be till, let's 10 to the power 18, and now we are just around 10 to the power 3, right? So great. We have optimized this, and I guess the digit DP thing would be clear to you. Now let's move to the problem, right? So I guess the video might be huge, but few things are left over here, right? So quickly let's talk about that as well. So what I'm trying to do is, if your count of I is equal to k, right? So is there any sense of traversing on those elements whose count of I is not equal to k, right? What do I mean by it, right? So if you look at this now, if your count of I is not equal to 2, then you should not traverse on that values as well, right? भाई समझ नहीं आया, यही मेरे को लग रहा होगा, तुम्हें लगा होगा, राइट? लेट्स से, क्योंकि मैंने भी जब ये फर्स्ट टाइम ऐसे प्रॉब्लम्स अप्रोच किए थे, तो दीज वर द थिंग्स कि वाई शुड आई डू दिस थिंग, वाई शुड आई check if count of I is equal to k or not, right? So count of I, what was it doing, right? It was seeing that to reach 1, right, what are the possibilities, or what is the pop count of any element till that point, right? क्या मतलब हुआ इसका? मैंने 2 का पॉप काउंट क्या लिखा था, अगर याद हो तो 2 लिखा था, राइट? वाई वॉज इट 2? वाई वॉज इट नॉट अ सिंगल डिजिट 1, राइट? Because 2 could be converted to 10 and 10 could be converted to 1. So according to any given question, you will have a pop count value of 1 and 2, but we are storing it as 2, right? Why? You will understand this, right? Okay. तो मैं कह रहा हूँ कि any pop count, see, first of all, we need to check that if that value is valid or not. Hold on. Again, sorry for the background noise, right? Let's start again from this part, right? So what I'm trying to tell is, we will start from I equal to 1, and we can go till s dot size. Now you can't exceed 111, right? You need to be in your range, in your limit, right? X should be in the range of this. So that's the reason we are traversing till s dot size, right? Okay, so now if count of I is equal to k, now why are we doing this? We want to find all the elements whose pop count depth is at least equal to k, right? If it's not equal to k, it's senseless to at least find that as well, right? So it should be equal to k. Great. So if you get a count of I equal to k, you create a vector, right, and call the recursion, right? So the recursion part is might be very clear to you now. Let's look at the code. I won't be skipping that part as well. So how are we doing the recursion, right? So index, I have made you understand what index stand for. Limit, what does this limit stand for? Limit stands for the number of set bits as 1, right? What does this mean? Means if I had a value, let's say 111, it has 3 set bits, so in my answer, right, I won't be exceeding this value, right? Means let's say count of I, when you find now, you found count of I, see this part, right? So when you found this count of I, you passed your I index as well, right? So how many bits, number of bits this represents, how many ones can you store, right, in your answer, right? So that's the reason you are passing this I over here, right? So this I function gets called, right? And now you know that this is your limit. You can't exceed 3 ones, or let's say you can't exceed 2 ones for now, right? So your answer should have at least 2 ones. Great. So if your limit is less than 0, you return a 0, right? If it's already limit is less than 0, that means you can't have any more ones, or you have already exhausted your correct opportunities, right? So you should return a 0, right? If index is greater than equal to s dot length, and if limit is equal to 0, return 1 ll. I hope this will have, might give you this sense that how this digit dp we were returning our base case, right? So if you reach to that length, and if limit is also equal to 0, that means you have reached the correct space, right? And if it's greater than 0 and the limit is not equal to 0, you simply return 0, right? And now simple one dp line code, right? If you have understood the recursive part, this dp line code might not be a new thing to you, right? dp of index, limit and type. If it's not equal to 1, return dp of this, right? Int limit, right? So if type is equal to 1, I made you understand this. Not this is same example, but the example was little different, so I will be explaining this as well. So let's say if your type was equal to 1, so limit will be sdx x of index minus 0, right? And else limit will be equal to 1, right? So if type was 0, type was 1, right? So what does this mean? Limit will be equal to sdx of I. See, yes. So what I'm saying is, if your type was equal to 1, right, means you don't have authority to change anything, right? Your limit will be the limit it had. Means if the string had 1, your limit will be 1, right? If the string had a 0, your limit would have been, see the mouse cursor, your limit will be 0, right? You don't have authority to add any index integer at this point. Are you getting this, what I'm trying to say? If not, let's take a small example, right? Let's say you are having 1 0, right? So at this point, let's say if you are wait, at this point, let's say you had a type of 1. So what does this mean? भाई टाइट 1 है, मतलब रेस्ट्रिक्शन है तुम्हारे ऊपर, राइट? यहाँ पे जो वैल्यू होगा ना, जैसे मैंने 5 4 7 6 जो भी यहाँ पे एग्जांपल था, तो अगर टाइट 1 था तो यहाँ तक का वैल्यू ही मैं ले सकता हूँ, राइट? तो मतलब 5 तक का वैल्यू ले सकते हो, राइट? सो योर लिमिट बिकम्स 5. इस केस में लिमिट क्या होगा? क्योंकि ये कैरेक्टर्स, ये भी कैरेक्टर के फॉर्म में होता है, बट इस केस में क्या होगा? इट विल बी एस ऑफ इंडेक्स माइनस 0, राइट? S of index is 1, so 1 minus 0 gives you a value 1. That is limit is 1, means you can go till 1, right? If it would have been 5, you could have gone till 5, but as it is a binary string, so it won't be 5, it will be 0 or 1 as well. and if your tight is equal to 0, your limit will be definitely 1, right? That, what does this mean? You can take any value, you can take 0, you can take 1, and binary ends over here, right? Okay, so now you will find num count, simple recursion which I taught you earlier, right? You will traverse from 0 till the limit value, right? Int new tight. What is this new tight? See, if tight equal to 1 and I equal to limit, then what does the tight become? New tight. Is it clear to you? Let's say you had a 1, right? And your tight was also 1, right? And you reached your limit, means you are standing at this 1, right? If you are standing at this 1, what will be your new tight? New tight will be 1, right? Because you can't escape. अगले इंटीजर्स पे या अगले कैरेक्टर्स पे यू नीड टू बी वेरी फोकस्ड कि तुम उस पर क्या रखोगे, राइट? लाइक 576, इफ़ अगर तुम 5 पे खड़े हो तो अगला इंटीजर तुम्हारे लिए बहुत महत्वपूर्ण हो जाएगा, बाप रे बाप, हाँ. सो new tight becomes 1, right? Else new tight is 0, you can traverse with anything, right? And after doing this, right, you are still in the loop, don't forget it. You count num count plus equal to, you call the recursive function again, and you store that in your dp, right? I guess the recursive dp digit part must be very clear to you, right? And if you look at the time constraints, right, the time complexity of this code, this is nothing but the dp's time complexity, which is big O of 66, right? Let's see what are the size of our dp, right? That will be simply our time complexity, right? So if you look, it is dp of 64, 64 and 2. So this is our time complexity as well. So I hope you have understood this problem statement, right? I will put the code in the comments. If you have any doubt regarding digit dp or any other topic or any other solution which you want from me, you can definitely write in the comments. I will definitely try to upload it. And please do like the video and subscribe my channel if you are new to this. Thanks for watching.